Hello everyone, welcome back to another session on our series on LabVIEW. We're still discussing for loops. There's just a small part that I think is very important for all of us to understand. What I have here is a program set up right in front of me. We are looking at the iteration number right here. We're displaying it in an iteration. We're going to see its value right here. This iteration gets added to an adder with a constant 5. So if the iteration number is 0, which is the first iteration by the way, so 5 plus 0 should result in 5, and we should see that value in sum. Okay, sum is going to give us the result of this addition, and that is getting fed into a shift register. In the next iteration, this sum value should be available to us right here, and we should be able to see this in the previous, this indicator that we have named as previous. So if I talk about the second iteration, in which the iteration number, loop iteration, would be 1, then 5 plus 1, the value of sum should be 6, but the previous sum should be available to us here in the shift register as 5. Okay, however, interestingly, and this is the part that I wanted to spend some more time in this session, is that when you add another element, you do a right click and you could add another element. Essentially what these are doing is, as we can see here, that you are able to, and if I just go ahead and display this number right here, then what exactly is this number? I am in fact able to access not only the previous value but the value even before it, right? So we were storing sums in the shift register, but if I display this shift register on the top left, I'm able to access the value of sum in the previous iteration. But if I look at this register at the bottom left, I'm able to access the value of sum even before that iteration. So I just want to run this with you once, and I'm going to pause it just to give you a glimpse of what's happening. So we're looking at the iteration 0. 0 plus 5 equals 5. That is what the sum is. Iteration is 0, indeed 0, and sum is getting stored in this register. Right now, as a default, there are no values in these registers, okay, because this is the very first iteration. So that is why we have zeros right here. Now we're going to let it run for one iteration, right? Okay, so as soon as iteration got to 1 from 0, 1 plus 5 is 6, our sum is 6, we have our iteration number 1, and in this iteration we have access to the previous result of the sum, right, which is right here. So the previous was 5, so that was the previous value of the sum, which is available here. Earlier than previous is still 0, okay, because we've only run the second iteration, and the only thing available to us is the result of the previous iteration. There is no iteration that exists earlier than that, so that is why it is still 0. Now let me run it for one more iteration, and as evident this time around, we have sum as 7 because this is the iteration 2, and 2 plus 5 is 7, and indeed we have it here. But have a look at what we have here. The previous is 6, which makes sense, but if you look at the earlier than previous, which is the bottom left register here, you're able to access the value of sum even earlier, that was stored even earlier than what we had in previous. So this is one way to access values that are available to us from iterations that are even earlier than what we have previously set up. So if I want to stop this, and if I just very quickly added another element here, and maybe I want to look at some value even before this, right? So let's go ahead and run this. This is for iteration 1, iteration 2, iteration 3. I'm going to pause it here, right? So if I go to iteration 3, I have the value of sum. In iteration 3, I have the value of sum displayed right here, but I have the value of sum in the previous iteration, and the one before it, and the one even before it. So that is a very simple way to access values or keep track of your iterations. Or if you wanted to use values from the previous iterations to compute them, maybe you want to use them, maybe you want to add them into your current sum for some application. And if it's not obvious by now, this is in fact what we do in the Fibonacci series. Okay, so this is what we try to implement in the Fibonacci series, where we are interested in the previous two values to compute the current value, right? The Fibonacci series is in fact the sum of the previous two values in the series to compute the current value in the series. Okay, so by making use of these additional elements on your left hand side, on additional registers on your left hand side, we can access the previous values and then compute our current value. So that could be one application of using these additional registers.